Hey folks, welcome back to another video. Today we're looking at question 153, find minimum in rotated array. The way we'll be approaching this problem is by using a binary search, but there are a few conditions that are associated with that just to get the minimum element. So let's jump right in. The first thing that we need to do is to actually cover the base cases as always. So the base case in this case would be if nums.length is actually equal to 1. That means that there's only one element in the array, and you would have to just return the first element because that would be the minimum. Nums of 0. Awesome. So the other test case you also need to check is that it's not rotated at all, right? So let's tackle that test case as well. So it would be nums.length minus 1. And then you check if nums of right, if it is greater than nums of 0 are left, that means it hasn't been rotated, and then our minimum element would be at the left, so you would just return nums of left. So these are the two base cases. If you don't return anything by this point, you would have to do binary search. So it would be while left is less than or equal to right, and in the end we don't really get anything, then you would just return -1. Awesome. So once you're in the while loop, you want to get the mid element. So you would say int mid would be equal to left plus right minus left divided by 2. And as soon as you have the mid element, what you need to check is that is the mid element involved in actually the array switch, and how would you do that? So you'd say if mid element, if it is greater than nums of mid plus 1. What does that mean? So that means at this point there's a switch. Let's look at an example, right? So in this case, if you're looking at 5 and this is a mid element, but if it is greater than mid plus 1, that means this is where the array has rotated, and you can just return the element at mid plus 1. You don't really need to think about it. This is where the arrays have been rotated, so it would be just returning mid plus 1. But you also need to look on the left side. So if nums of mid minus 1, if this is greater than nums of mid, this means that the left element, which should have actually been smaller than the element on the right, if that's the case, that means that's where the switch has happened, so you can just return the mid element. And if these two cases are not hit, then you need to check if nums of mid, if it is greater than nums of 0, that means the left side of the array has been sorted, and it's fine. You don't really need to worry about that. That means there is no rotation of any sort. So you need to look on the right side of the array. So you just say left is equal to mid plus 1. If not, you move to the left side of the array, and you can do that by assigning right to be equal to mid minus 1. Awesome. So this is actually the solution. It's pretty simple if you understand what are the conditions you need to check. Let's go ahead and compile this. Right, of course. Let's try that again. The first test case is okay. Everything else is okay as well. Awesome. Let's talk about the space and the time complexity. The space complexity of the entire solution is log n because it's a binary search, and that's the time complexity, and the space complexity is of 1 since we're not really using any additional space to store any data. Awesome. So that's the solution. If you have any questions, please let me know in the comments below. Don't forget to subscribe and like the video. I would really appreciate that. It motivates me to make more videos. Thanks so much, and I'll see you all in the next video. Peace.